The Eiffel Tower in the heart of Paris, a milestone in architectural history.
When it was built, the Eiffel Tower broke all records.
And today, the most visited tourist attraction in the world. But what happens when this legend meets a modern-day tower icon?
This really is a duel of the giants.
The Eiffel Tower faces Tokyo Skytree, the highest freestanding tower in the world. A marvel of modern technology. A tree that literally grows into the skies.
To build such a high tower in one of the most earthquake-prone areas of the world, that's pure madness.
A contest of superlatives. 2 opponents, 3 categories, and lots of surprises. Construction. How complex was it to build the giants? Features. Which mega tower has the more innovative technology? And architecture. Which tower revolutionized architecture? We are about to find out now in Legends versus Modern Icons. France, 1887. For the World Exhibition in Paris, the French wanted to create a new wonder of the world to celebrate the centenary of the French Revolution, the origin of democracy in Europe. The idea was to construct a tower 300 meters tall, twice as tall as any other building at the time. Its engineer, Gustave Eiffel.
Eiffel had a vision. He wanted nothing less than a revolution in architecture.
And indeed, the tower broke every record. At the time of its construction, it was exactly 301 meters tall. Yet, remained a lightweight at just 10,100 tons, revolutionary in relation to its size. Eiffel's brilliant idea was simply to use steel instead of stone. Precisely 7,300 tons of iron and 2.5 million rivets. To get to the top, visitors needed to climb 1,665 steps, or use 3 separate, specially designed lifts.
The Eiffel Tower had only one task: to amaze the whole world.
Astonishingly, the tower was to then be demolished 20 years after opening.
Eiffel simply could not allow that. He had a brilliant idea to save his tower.
Eiffel's architectural masterpiece was to become the first television tower in the world and the symbol of Paris. Almost 100 years later, on the other side of the world, Tokyo was growing rapidly. Ever higher skyscrapers shot out of the ground. A gigantic tower was needed to enable radio signals to be clearly transmitted. In 2011, the Japanese Tokyo Skytree made history. At 634 meters, the world's tallest broadcasting tower made it into the Guinness Book of Records. The steel structure alone weighs 36,000 tons, as much as 200 jumbo jets. The new landmark of the Japanese capital is made from steel, reinforced concrete, and glass, standard materials for contemporary times. Even in the 21st century, it still has a stairway with 2,543 steps. But visitors prefer to use one of the 6 high-speed lifts.
Tokyo Skytree is a technological wonder.
Can the modern icon compete with the legendary tower? Round 1, construction. How difficult was it to build the giant structures? The contest begins at the bottom, at the foundations. Paris, 28th of January, 1887. 2 years before the planned World Exhibition, work began on the Eiffel Tower on the former Champ de Mars military site. But the first problems emerge shortly after digging begins. Flooding in the area where the tower was to be built. The ground was mud.
Despite previous soundings, Eiffel was not sure if the ground would support his gigantic construction.
No wonder. Soft ground had already caused many a tower to lean, like Pisa's tower. In 1873, just 1 year after construction had started, the tower begins to tilt.
At that time, the architects hadn't considered actually that at this specific point, the soil consisted mainly of loose loam and sand.
The ground began to subside under the tower's weight. The construction still tilts by almost 4 degrees today. While this would make the one tower world famous, for the prestige project for the Paris World Fair, it would be a catastrophe. The groundbreaking solution was to rest each of the tower's 4 feet on separately formed pyramid-shaped rising pillars. Stabilizing the ground in this way revolutionized foundation construction around the world. But there was another problem. 2 of the tower's feet were to stand right on the banks of the Seine. This required digging foundations deep into the riverbed.
Gustave Eiffel did not allow anything or anyone to dissuade him from his ideas. It is thanks to his revolutionary approach that the Eiffel Tower is standing on solid ground.
Eiffel lowered sealed metal chambers into the river. Workers inside then excavated the sludge, with compressed air keeping them dry. The more they dug, the deeper the chambers sank, until they reached a solid limestone layer. The chambers were then filled with cement and gravel, the basis for the concrete foundations. The foundations on the Seine side reach 14 meters deep into the earth. On the other side, 9 meters.
What an effort, what a show. The world had never seen anything like it.
The task was challenging. The solution spectacular. The Eiffel Tower impresses in the foundations category. The Tokyo Skytree also presented enormous challenges to its engineers. The tower was to be more than twice as high as the Eiffel Tower, and, of all places, in a top earthquake country. No other industrialized country is as earthquake-prone as Japan. An average of 73 earthquakes with magnitudes of 4 or higher occur here per month. Up to 70 perceptible earthquakes shake the Tokyo metropolitan region every year. The most severe since records began was the Tohoku earthquake in 2011. It triggered a tsunami more than 14 meters high, and the Fukushima nuclear disaster.
Japan, and especially Tokyo, must be, in principle, always ready for the next quake.
Earthquakes, a constant danger. The Tokyo Skytree required extremely secure foundations. Reflecting the tower's name, the foundations needed to be like a tree rooted deep in the ground. To achieve this goal, the engineers sank 3 massive piles made from steel reinforced concrete 50 meters deep into the ground. These were special because, rather than being round, they were made up of a grid of steel plates arranged in a star shape. In the ground, they fan out like the roots of a tree. Additional stability is provided by double reinforced concrete slabs that connect the roots up until a depth of 35 meters.
So the principle is ingenious. With every meter of ground depth, the friction increases. So this foundation technology is actually unique worldwide.
The conditions at Tokyo Skytree were challenging. The solution was simply groundbreaking. The two towers are in no way inferior to each other regarding foundations. Both locations have special challenges, which engineers met with spectacular solutions. Round 2. What machinery has revolutionized tower construction? At the end of the 19th century, heavy machinery didn't exist. How was Eiffel able to build his legendary tower? The most tricky step was the construction of the first floor. 4 horizontal supporting beams were to connect the 4 feet at a height of 50 meters. The steel beams needed weighed 70 tons. Eiffel's brilliant idea was to use guide rails on the lifts to transport them upwards.
He simply placed steam-powered cranes on the rails. They climbed up with the tower, so to speak. No one had ever seen anything like it.
But how did he manage to precisely align the huge steel components? Here too, Gustav Eiffel developed an ingenious system. The workers used hand pumps to operate huge hydraulic jacks. They brought the 4 gigantic tower feet into position. An ancient trick ensured that each was at the same level. Eiffel placed sandboxes between the scaffolding and the metal construction. The workers released sand from the boxes until the pillars reached the right heights.
Only with this groundbreaking combination of modern technology and ancient knowledge was it possible to build the world wonder Eiffel Tower.
The first important milestone had been achieved. The rest of the construction was, in comparison, child's play. The tower's construction was, for the time, a technical masterpiece. In the 21st century, state-of-the-art technology was used in the construction of the Tokyo Skytree. Due to the exceptional height of the tower, the slightest deviation from the building plans could have weakened the entire structure.
The construction of a 634-meter tower is a demanding project in every respect. It requires extraordinary precision and technical innovation.
For the construction, engineers set up a fully automated production plant on site. A vertically movable factory known as a super construction factory was located at the top of the building. During the construction process, it moved upwards floor by floor. A subsystem ensured the steel beams were precision aligned. A laser scanning system monitored correct installation by cross-checking with the planning data.
It is simply incredible what is possible today with the help of modern systems and robotics.
The Tokyo Skytree, through the factory at its top, literally grew upwards into the skies bit by bit. Brilliant. The verdict on round 2. The resources available combined with adaptation to each structure's special conditions make both towers highly revolutionary. The final round on construction, logistics. Who was actually fastest in building their towers? Paris, 1887. The foundations had been laid, but time pressure was enormous. The World Exhibition was to take place in just under 2 years. The Eiffel Tower had to be finished by then. An ambitious time schedule. Mega buildings of the past had not exactly shown in terms of construction time. The Great Pyramid of Giza, 140 meters tall, took 20 years to complete. Cologne Cathedral was inaugurated only after a record-breaking 632 years of construction. And the USA spent a whole 36 years building the 160-meter tall Washington Monument. To speed up the construction process, Eiffel had the complete tower designed and pre-made at his company's headquarters in Les Valois-Perret.
Eiffel was the inventor of the modular principle, so to speak.
His workers made the 18,000 individual parts of the tower to the 10th of a millimeter. Up to 300 workers at the construction site then assembled the precision-fitted parts.
This was Gustave Eiffel's secret and made him the greatest engineer of the time.
Just 22 months after the start of construction, the tower was completed. It grew about half a meter a day. At the end of March 1889, the engineer Eiffel climbed his own tower for the first time and hoisted the French tricolor. 301 meters tall, in 2 years, 2 months, and 5 days, including the foundations. For the time, an absolute record. Can the Japanese challenger top that? Tokyo, 14th of July 2008, the groundbreaking ceremony for the construction of the tallest tower in human history. Despite its extraordinary height, the Japanese tower needed to be stable enough to withstand earthquakes and hurricanes. Its design also made huge demands.
Height, safety, beauty. These three factors run counter to each other, but must be brought into harmony.
The idea, the tower was to change shape as its height increased, from a triangular form at the bottom to a circular shape at the top. To be able to build the Skytree quickly, despite its complex design, the engineers took a clever approach. Inside the steel core, an automated logistics system brought materials from the ground to the installation site, to the right place on the right floor. Robots then precision welded the elements and created the world's highest tower as if by magic.
The further development of the robot-supported construction process for the Tokyo Skytree is legendary and trend-setting.
But despite all the automation, without humans, things wouldn't work. 580,000 workers were involved in the construction process. After 3 years and 8 months, the task was accomplished. Despite the Skytree's state-of-the-art logistics systems and many times more workers, construction time was only slightly faster than the Eiffel Tower, built in the century before last. The two towers had completely different designs, building materials, and machines, and yet they had one thing in common. The speed at which they were constructed was revolutionary. In the first category construction, the Eiffel Tower and the Tokyo Skytree are equally impressive. Each, for its time, used revolutionary innovations. But how do things look in the next category? Features. Which megatower has the more innovative technology, legend or icon? Round 1, which has the more sophisticated lift system? Lifts are nowadays taken for granted. At the end of the 19th century, however, they were a technical novelty to the general public and were considered dangerous.
Elevators were not 100% technically mature at the time, at least in people's minds.
Yet, climbing 1,665 steps was unthinkable for Gustave Eiffel. His vision of getting to the top required 3 separate systems. Up to the first floor was easy. The legs of the columns were wide and straight. A standard lift system was sufficient here. 2 large cars were running on rails already installed during construction on the north and south pillars of the tower. But the strong curvature of the struts from the first platform upwards required a special lift design.
The goal was to achieve a mixture of the cable car and the elevator.
Lift specialists at Otis were developing a world first. 2 huge hydraulic cable lifts followed the inclination of the tower. Transporting people from the second to the third floor was even more complicated. The lift had to bridge a height difference of 160 meters.
At that time, no one had ever done that.
Once again, the engineer Eiffel excelled with a brilliant idea. He halved the travel distance by installing 2 lift cars running in opposite directions. The 2 cars were kept in balance by a cable. When one car went up, the other went down. Visitors stopped halfway up, changed cars, and then traveled on to the very top.
The world had never seen anything like it before.
At the time, the journey to the top took a total of 10 minutes. The system remains largely intact today. One reason why the Eiffel Tower lifts are an attraction in themselves. Each year, they travel a total of 103,000 kilometers. In other words, 2.5 times around the world. The lift technology in the French Eiffel Tower was pioneering, revolutionary, and very ingenious. And in Japan? The Tokyo Skytree's first viewing platform at 350 meters is alone higher than the entire Eiffel Tower.
So technically seen, purely overcoming the height is actually not the biggest problem.
Today, it's more about speed and efficiency. The 6 elevators in the Tokyo Skytree are among the fastest in the world, with maximum speeds of 600 meters per minute. They can transport up to 40 people simultaneously to heights of 445 meters.
The only thing that could get in the way of these highly technological machines actually is earthquakes.
In disasters, lifts normally stop for safety reasons, with sometimes dramatic consequences. In the Great Earthquake of 2011, lifts in 84 buildings in Tokyo halted. People sometimes had to wait over 9 hours in the cramped cars until rescue arrived. The Tokyo Skytree's lifts are therefore equipped with a special safety system. Earthquake sensors detect vibrations in the building and calculate in real time expected vibrations of the lift cables. If vibrations are excessive, the lifts can still be operated manually. The technology enables the lift cars to still reach the next floor in the event of a disaster.
This feature makes the elevators in the Tokyo Skytree one of the safest in the world.
Verdict: both lift systems used highly innovative technology for their time, something exceptional compared to other systems around the world. We now continue with features. Which tower has the more innovative lighting system? In the 21st century, light spectacles characterize the cityscapes of the world's mega metropolises. Light is considered modernity's immaterial building substance, and it is, first and foremost, pure show. But what was the situation when the Eiffel Tower was built? In 1889, the idea already existed of using the Eiffel Tower as a kind of lighthouse. From the top, spotlights were to illuminate the streets of Paris, and in this way replace street lamps.
Of course, that didn't work very well, but the idea to light the tower had been born.
On the inauguration evening, 10,000 gas lamps illuminated the new wonder of the world. The blue, white, red beacons were at the time the most powerful in the world. A few years later, in the mid-20s, Citroën achieved a spectacular advertising coup. For 9 years, the car maker's logo illuminated Paris, while also serving as a guide for the U.S. aviation legend Charles Lindbergh after his Atlantic crossing. Today, the Eiffel Tower's lights are state-of-the-art. The spotlight at the top of the tower emits a rotating beam of light that can be seen for an impressive 80 kilometers. "20,000 lamps light up every hour for 5 minutes. And on special occasions, brilliant light shows take place in the most extravagant colors.
The light shows have almost become an attraction in their own right.
But beware, the Eiffel Tower's illumination is copyright protected. This means posting an image of the illuminated tower on social networks without asking can become very expensive. Since the tower's construction, its lighting has always adapted to the moment and has been spectacular every time. What about its modern-day contender in Japan? The Tokyo Skytree was not only to become the highest radio tower in the world, but also a symbol of its time and Tokyo's #1 landmark. The goal? Its illuminations were not only to light up the evening sky, but also to symbolize Japan's past, present, and future, combined with maximum energy efficiency.
Nowadays, nothing can be installed without considering the environmental aspect.
To achieve maximum light output with minimum power consumption meant LEDs. The Skytree is a pioneer in this respect. LED lamps had only been on the market for a few years. Although red and yellow-green LEDs had been available for some time, there was no blue to create a white base and thus the entire color spectrum.
This really was an unsolvable problem for decades.
The lighting market revolution began in Japan in the 90s. 3 physicists finally invented an efficient blue light emitting diode. In 2014, they received the Nobel Prize in Physics for their invention. The Tokyo Skytree was one of the first buildings in the world to use the new technology as its only light source. An incredible 2,075 LEDs light up the tower every single night.
With the help of this technology, unprecedented light shows are possible.
And it's environmentally friendly too. Compared to conventional light sources, the lighting system is 43% more efficient. The Tokyo Skytree uses the latest and most innovative lighting technology. The Eiffel Tower has repeatedly reinvented itself over the course of time. Both towers are capable of spectacular light shows. The final comparison in the features category: for what purposes are the towers used? Or, in other words, which tower can do more? In 1889, the Eiffel Tower served only as the entrance to the World Expo, a prestigious object without any other real purpose, except perhaps the firing of a cannon twice a day to announce the time, like a bell tower.
So from a very pragmatic point of view, it really is no wonder that Paris wanted to tear down the Eiffel Tower after 20 years.
But the engineer Gustave Eiffel always came up with clever ideas to ensure the tower's survival. Shortly after the tower's opening, Eiffel began to use his architectural masterpiece for scientific experiments. He set up a meteorological laboratory on the 3rd floor.
The big advantage was, of course, the unprecedented height difference of 300 meters.
This was followed by gravitational studies and new aerodynamic knowledge from a wind tunnel installed at the foot of the tower. The tower's eventual salvation came only at the turn of the century. Eiffel offered use of the tower for the first radio experiments while also undertaking the costs. In 1903, France installed the first antennas on the tower. 3 years later, Gustave Ferrier succeeded in establishing the first wireless connection from there.
This was the breakthrough in the field of radio technology at the time.
On the 1st of January 1910, the city of Paris renewed Gustave Eiffel's concession. The tower was to stay. Since the mid-30s, the architectural legend has also served as a transmission mast for the new medium of television, and continues to do so today.
In the end, a wide range of possible applications saved the tower.
The Eiffel Tower has meanwhile become the world's #1 tourist magnet. 7 million people visit the nation's landmark every year. And it has had a surprisingly varied history of purposes. What began back then would, in the following years, change the world. In the 1950s, television became the new mass medium par excellence. In 1961, global television audiences already numbered over 100 million. The demand for reliable broadcasting technology was constantly on the rise. Accordingly, the Skytree is first and foremost a high-performance transmission tower. Due to its elaborately designed viewing platforms, it is also, like the Eiffel Tower, becoming a tourist magnet. Almost 5 million people a year enjoy the breathtaking views of the Tokyo region.
For a television tower, this definitely is impressive.
But that's not all. In the world's tallest tower, scientists also study lightning strikes, air quality, and greenhouse gases. Research that would otherwise require an aircraft, such as studies into the formation of clouds. At an altitude of 458 meters, researchers on the Skytree can observe the size and number of tiny droplets in the air. This data helps them analyze how clouds form.
This is, of course, an incredible advantage of this impressively high tower.
Japan's ambitious goal was to develop a cloud radar system for the early detection of torrential rainfall. But the Tokyo Skytree is not just an early warning system. Its extremely safe construction enables it to withstand natural disasters, such as earthquakes and typhoons, and to continue transmitting under any circumstances.
Even if everything on the outside collapses, it should still function as a civil protection facility.
For this reason, located in the immediate vicinity of the tower are a shelter, a warehouse with emergency supplies for 3,000 people, and an underground drinking water reservoir to supply the population. Verdict: the Tokyo Skytree is more than just a television tower. It's used for a diversity of research, and its role in disaster management make it absolutely unique. In terms of features, both contenders are tied. Japan's gigantic tower was a high-tech giant from the outset. The Eiffel Tower, on the other hand, has repeatedly reinvented itself and continues to broadcast today. What about the final category? Which tower revolutionized architecture? In the first round, we look at engineering as an art, or to be more precise, the design.
The Eiffel Tower is undisputably considered an icon of architecture. Why? Because its design is not only visually appealing, but also the result of ingenious engineering.
Like no other structure before it, the Eiffel Tower triggered a worldwide wave of tower construction. Many of them were based on the Eiffel Tower's design. Some even copied it. One of its first replicas was the Blackpool Tower in England, inaugurated in 1894. But at 158 meters, it is a good deal smaller. Built in 1958, the most famous replica was the Tokyo Tower in Japan. and at 353 meters, it was even slightly taller than the original. The tower's twin on the legendary Las Vegas Strip is only half as tall and was built in 1999. What mainly makes the Eiffel Tower's design so special is its square floor plan with 4 pillars, spaced 74.24 meters apart. The feet are positioned precisely according to the cardinal points. 16 vertically staggered iron struts and groups of 4 rise up into the sky in the shape of an arch. They connect 3 visitor platforms at 57, 115, and 276 meters.
The well-thought-out and thoroughly complicated architecture is at the same time so simple that it can only be described as a stroke of genius.
Not only that, also in terms of design, it eclipsed any other building of the time. Revolutionizing architecture worldwide. No other tower has found so many imitators. Can the youthful Tokyo Skytree match that? Since the Eiffel Tower, towers need to be much more than just functional. They are a landmark for both their cities and countries. Everyone wants their very own world-famous tower. Architects are therefore experimenting with the most diverse forms.
Design today is much more than just what something looks like. Simply, each element should express its own message.
The Tokyo Skytree has taken this trend to the extreme. The triangular shape at its base also reflects its location, because the tower is located exactly in the middle of a triangle formed by the Sumida River, the Arakawa River, and the Tobu Railway transport system. From a triangle at its base, the tower transforms into a cylindrical form at a height of 350 meters. Depending on the angle of view, the Tokyo Skytree always looks a little different, a symbol of uniqueness and originality. The tower's profile is inspired by traditional Japanese principles, sori, concave curves, and mukuri, convex curves. From ancient temples to the world-famous samurai swords, the link between sori and mukuri is deeply rooted in Japanese culture.
The Japanese are true masters in combining tradition and modernity, past and future.
The Tokyo Skytree is ultimately much more than just a television tower. Its design is simply breathtaking. However, it is still too new to make a claim as an architectural revolutionary. The Eiffel Tower, at more than 100 years old, still has that advantage at the present. The next round in the architecture category, statics. How were the engineers even able to reach such previously insurmountable heights? In the 19th century, the 1,000-foot mark, around 300 meters, was an obsession among engineers and architects. It was primarily a contest between America and France. Who was to be the first to make the mark? The problem concerned building materials. Up to the 19th century, towers were mainly built from wood or stone.
The higher you want to build, the more loads the material needs to support.
Both building materials have inherent problems. Wood, as a natural material, loses its stability above a certain height. Stone is stronger, but also heavier. The higher the building, the more the pressure on the lower floors increases. Consequently, the heights of buildings had been limited to less than 200 meters since the Gothic period.
Everyone knows how the Eiffel Tower broke the height record. The secret lies in the building material, steel.
Steel has impressive static properties, stable and relatively light. In relation to its size, the Eiffel Tower is a featherweight. It's weighing just as much as a box of air with the same base and height as the tower, 10,100 tons. But there are different types of steel. Eiffel uses what is known as wrought iron, that is, forged iron, the same material used for horseshoes.
Gustave Eiffel's creative use of iron brought him incredible fame. He became known as the magician of iron.
His reputation as a brilliant engineer had already been cemented with impressive constructions, such as the Ponte Maria Pia near Porto, or the Garabit Bridge in the Massif Central. The Eiffel Tower's jointing technique also follows the bridge building tradition. Rivets, 2.5 million of them, keep the tower together.
Light and at the same time, absolutely watertight. Statically speaking, this is the optimum combination.
The Eiffel Tower was therefore also an absolute pioneer in terms of statics. The combination of building materials and jointing technique was unique for the time of its construction. The Tokyo Skytree is also made mainly of steel. No wonder. The higher the construction, the more relevant is the dead weight of the material used.
From a static point of view, the relationship between the height and the width is one of the most important factors for towers.
The Tokyo Skytree has a ratio of 9:1. It's 9 times higher than it is wide.
This really was one of the biggest challenges of the Skytree.
The solution? The tower body itself consists of an intricate steel skeleton. The high-strength steel pipes are twice as strong as standard frameworks. The piles used for the tower base are 2.3 meters wide and 10 centimeters thick. To provide additional stability, the tower's core has a cylindrical column of solid reinforced concrete. The secret in both towers is the building material, coupled with a construction method. The legend and the icon are extremely stable. But what happens when nature and technology come face to face? The final round in the architecture category, resilience. How do the towers defy the forces of nature? Storms, floods, and earthquakes are natural disasters that often leave devastating damage behind them and stop at nothing. Storms were the greatest danger to the Eiffel Tower. Experience with such a monumental building was lacking at the time. The designers were concerned about whether the tower could withstand the wind forces at heights of 300 meters.
Throughout his career, Eiffel was worried about the wind.
To address the problem of wind vulnerability, Gustave Eiffel again came up with a revolutionary approach.
Eiffel played it safe. His calculations are based on hurricane wind forces of up to 400 kilograms per square meter.
The steel truss construction was designed in such a way that wind forces were directed towards the ground by the tower's shape. The trick was to have the tower's supports run along the line of thrust, an imaginary line in the center of the structure where vertical and horizontal forces come together. The lattice-like construction of the tower provides additional stability. The wind blows through it without exerting great pressures on the structure.
Even at wind speeds of up to 200 kilometers per hour, the top of the Eiffel Tower sways by a maximum of 18 centimeters.
Wind is therefore hardly a concern to the Eiffel Tower. The ingenious lattice-work construction is extremely robust against the forces of nature. How is it with the Tokyo Skytree? Wind is not the greatest danger here, but earthquakes definitely are. 2,000 times a year, the Earth's plates move and shake Japan. An everyday occurrence, but also an ever-present danger. The country lies on the Pacific Ring of Fire, where 4 continental plates collide. Volcanic eruptions, tsunamis, anything is possible at any time. And Tokyo, with its more than 30 million inhabitants, is located right in the middle of the danger zone.
Actually, due to the extremely high tectonic activity, Japan has a natural limit of 600 meters for buildings.
The Tokyo Skytree exceeds this limit by 34 meters. How is that possible? The engineers found the solution in ancient architectural knowledge. Traditional Japanese pagodas. The mostly 5-story tower-like structures were initially used for the safekeeping of bones and other remains of Buddhist monks. The designers worked for years on the construction until they developed an earthquake-proof system by decoupling the individual elements.
The basic elements of earthquake resistance have existed for centuries.
The Skytree's engineers made use of exactly this knowledge. The secret lies in the technology of the Shimbashira Saishin. A main central pillar forms the heart of the tower. Its special feature is being decoupled rather than rigidly connected to the antenna mast, an external steel structure. Oil dampers buffer the connection between the concrete core and steel skeleton. The advantage is that each component can react differently to vibrations. If all the tower's components were rigidly connected, the vibrations would multiply over the height of the building.
The resulting hybrid technology for earthquake resistance makes the Skytree safer than any other building of similar height.
Both towers were built for eternity. Ingenious systems and meticulous calculations ensure that they will probably forever defy the forces of nature. The verdict on architecture. The Eiffel Tower and the Tokyo Skytree are masterpieces and hold an exceptional status compared to their worldwide colleagues. More than 100 years lie between the construction of the Tokyo Skytree, the iconic mega tower of modernity, and the legendary Paris Eiffel Tower, the most popular building in the world. And whether in terms of construction, features, or architecture, both are more than just towers. They are symbols for the time of their construction, for their country, and for their people. They dominate their city skylines, magnificent, radiant, and for eternity.